This demonstration shows the key benefits and features of the iGraphics Lean Value Stream Map diagram types available in all iGraphics graphical modelers. iGraphics is the ideal tool for value stream mapping. Imagine drawing in 15 minutes what used to take 5 hours of work in other tools. All the value stream symbols and lines are formatted as expected. The push line, for example, includes an inventory shape. A timeline with humps and valleys is automatically drawn for you. It highlights value added, non-value added, and lead times. A distance line is also available. The work balancing graph aids analysis and identifies process steps that are not aligned with takt time. Publish diagrams to PDF, Word, PowerPoint, and the web. Also, import and export data to Excel. iGraphics includes additional tools for cause and effect diagramming, FMEA, prioritization matrix, SIPOC, layout, and pick chart analysis. Choosing Lean Value Stream from the New menu initializes my map with a starting set of shapes and lines. Before detailing my value stream for producing steering brackets, I enter some initial values about the value stream flow. I have 2 worker shifts with 20 minutes of break time per shift. My customer demand is 18,400 pieces per month, giving me a takt time of 60 seconds per piece. I specify demand by month, but I could use any time unit desired. The automatic timeline is turned on. I'll discuss this and also the work balancing graph in more detail later. I'm now ready to construct my value stream. To add process steps, I simply choose the process shape from the Toolbox toolbar and drop it onto the diagram. By clicking down on one shape and dragging, I insert a shape and its connection line. Yellow inventory shapes are automatically placed on the push lines. The most common shapes are on the Toolbox toolbar. In addition, more shapes are available in the gallery on the right. To change line styles, I simply choose the line style from the Toolbox toolbar. While remaining in standard editing mode, I can enter labels for my shapes. In this example, my first 2 shapes are the stamping and welding steps. I right-click and choose Properties to add lean data to each step. For stamping, I know that the total cycle time, or processing time, is 1 second, the time for 1 unit to move through this step. I have 1 operator and an 85% uptime. The distance traveled is 30 feet. Earlier, I specified 2 shifts. I can override this calculated value, and I can also specify if I want this shift value to be visible on the shape data block. While the Properties dialog box is up, I'll enter data for other shapes in the diagram, including the welding step and the accumulated inventory between these 2 steps. The data block and operator symbol are now visible on the process step. The timeline valley displays the value added time. For stamping and welding, this is the same as the total cycle time I entered. Multiplying inventory by takt time produces a lead time of 7.61 days. Lead times and non-value added times are shown on the timeline humps. Alternatively, the inventory lead time can be based on the processing capacity of the next step in the value stream flow. The timeline shape is based on the position of process steps in the flow. It's easy to customize VSM diagrams to meet your organization requirements. For example, I'll add a field that shows a calculated value for production time. Clicking the field name shows me the formula used to determine the value. In addition, instead of the Pieces Inventory field, I want inventory shapes to use 2 fields to represent inventory amounts for both left-hand and right-hand parts. I'll customize the display and I'll update the value for one of the inventory shapes. The timeline displays totals for lead time, processing or value-added time, work in process time, and raw material and finished goods time. The timeline can be customized to show calculated values like process efficiency and totals for any data field. Parallel flows are easily handled by the timeline. Here, I'll add a process step parallel to the stamping step. The total cycle time of the stamping step is 1 second. The total cycle time of the step beneath it is 5 seconds. The timeline automatically displays the processing time for the longer of the two steps in the parallel paths. I've finished my current state map. Now, let's analyze the map in more detail. Along with the timeline, a distance line showing the length of travel and a work balancing graph are displayed. Distances between and within activities can be shown. The work balancing graph displays multiple VSM elements. Production times are represented by the bars for each process step in the value stream. The takt time and takt time goal are shown by lines across the graph. Ideally, in a smooth, continuous flow, production times are close to the takt time goal. The assembly step production time is above the takt time goal. Adding another operator to this step is one way to bring production time down. Processing time, 62 seconds, is not affected. The graph, however, shows the impact of the resource change. All steps are now within the takt time goal. The work balancing graph also displays process step non-value-added time. If my welding steps have 5 seconds of non-value-added time, that is shown on the bars and labels of the graph. The ability to export and import VSM data to Excel also enhances my analysis. I can export to 3 different formats and use a custom format if desired. Here is my exported VSM data. Exported files can be modified and imported back to the value stream map. For example, I'll modify the total cycle time of the stamping step, save the file, and return to my map in iGraphics. Here, I'll use the lean import command to update my map with the Excel data. The stamping step has now been updated from a total cycle time of 1 second to 5 seconds. Extended value stream, or EVSM diagrams, broaden the scope to span multiple facilities or services across the organization. For example, the gamma stamping shape on this EVSM diagram is linked to a separate VSM diagram detailing the stamping flow. All values for this shape, such as the 3000 value-added seconds, are rolled up from the child diagram. If I change the lower level flow, such as adding 10 more seconds of value-added time, the changes are rolled up to the parent diagram and displayed on the data box and timeline. After analyzing my current state diagrams, iGraphics provides the shapes and tools required to build future state EVSM and VSM diagrams that reflect the improvements identified. For example, in a future state VSM map, supermarkets often replace push flows. Also, Kanban symbols and Kaizen work bursts are frequently used. In summary, iGraphics provides all the tools and benefits lean practitioners are looking for in a value stream mapping tool.